Hey there, and welcome. Have you ever just stopped and wondered what everything around you is, well, made of? I mean, from the phone in your hand to the very air you're breathing, it all boils down to some pretty cool core ideas. So today, we're going to dive in and explore the fundamental properties of matter.
Okay, so let's kick things off with a quick question. Picture a heavy bowling ball, a super light balloon that's all blown up, and the invisible air all around us. On the surface, they couldn't be more different, right? But, believe it or not, they all share one single fundamental thing. Any ideas what that might be?
The answer is, they're all made of matter. Yep, that's the secret ingredient. It's the universal building block for pretty much everything you can see, touch, or even feel.
Now, to really wrap our heads around this, we're going to open up what I like to call our scientific toolkit. Think of it as a set of tools that lets us inspect, measure, and understand the world around us piece by piece.
So, what's the official definition? Well, it's actually super simple. Matter is just anything that takes up space and has mass. That's it. So solids, liquids, gases, they all count. If it's got some substance to it and it's taking up some room, you're looking at matter.
All right, let's pull out the first couple of tools from our kit. See, before we can even begin to describe matter, we have to be able to measure it. And everything really starts with two key concepts: mass and volume. First up, we've got mass. Now, it's really important not to mix this up with weight. They're not the same thing. Mass is, in simple terms, the amount of stuff that's packed inside an object. It's all about how much material is actually there. Here's a perfect way to picture this. Think about a baseball and a bowling ball. They're kind of similar in size, right? But you know that the bowling ball has way more mass, simply because there is a lot more stuff packed into that same amount of space. Okay, our second tool is volume. And if mass is about the stuff, then volume is all about the space. It's a measurement of how much room an object physically occupies. It's not about what's inside, it's about how big it is on the outside. The balloon is a great example. The actual air inside doesn't have a whole lot of mass, but once you blow it up, it takes up a lot of space. It has a high volume. So just remember, mass is the stuff and volume is the space.
Cool, so now that we know how to measure matter, let's grab the next set of tools from our kit. These are all about observation. We're going to start with what are called physical properties. And the key here is that these are things we can observe and measure without actually changing the substance itself.
So our first little test is all about energy. Let's imagine we have a material. Can we pass heat through it? What about electricity? Asking this question reveals a really important property. And that property is called conductivity. Some materials, like copper and aluminum, are fantastic conductors, which is why we use them for electrical wires. Energy just flows right through. But then you have poor conductors, like the rubber or plastic that coats those wires. And thank goodness for that. That property is literally what keeps us safe when we plug something in. All right, next tool. Let's look at how an object plays with light. When you shine a light on something, what happens? Does that light bounce right back at you? This is how we test for its reflectivity. And the result tells you a lot. Things with high reflectivity, like a mirror or a polished metal, look shiny because they're bouncing most of the light back. But things with low reflectivity, like a piece of dark cloth or rough wood, they actually absorb more of that light, and that's why they look dull. Okay, next up, let's try a simple but really powerful test. What happens if you take a substance, drop it in water, and give it a good stir? Does it just disappear, or does it kind of just sit there at the bottom? This property is called solubility, and you see this one every single day. Things like sugar and salt are soluble. They dissolve and seem to vanish in your coffee or tea. But sand, not so much. It's not soluble, so it just sinks right to the bottom. It's a simple observation, but a super fundamental physical property. And for the last tool in our physical properties tray, let's bring a magnet into the picture. What happens when you bring it close to an object? Does anything happen? Does it get pulled in? This, of course, reveals its magnetism. Some materials, like the iron in a simple paperclip, are magnetic, but most of the things around you, like paper, wood, or plastic, they aren't. And again, notice we've learned something crucial about the object without changing it one bit. Okay, now we're getting to the really dramatic part of our toolkit. So far, everything we've done has just been about observing matter as it is. But now we're going to look at the properties that describe how matter can completely transform into something new. And this is the absolute key difference.
A chemical property isn't about what a substance is right now. It's about what it could become. It describes its potential to go through a change that creates a totally brand new substance.
Flammability is the perfect example. It's a chemical property of wood. When you burn a piece of wood, it undergoes a chemical change. The wood itself is gone. In its place, you have totally new substances, ash and smoke. And there's no going back. You can't turn that ash back into a log. It is a permanent transformation.
So, after exploring our entire toolkit, let's step back and put it all together to see the big picture. It turns out, everything we've just talked about neatly falls into one of two main categories.
And here it is, the main takeaway. On one hand, you have physical properties. These are the things you can observe without changing what the substance is made of, like checking if that paperclip is magnetic. And on the other hand, you have chemical properties. These describe a substance's potential to become something new, like wood's ability to burn, or even that same paperclip's ability to rust over time, changing from shiny iron into a new, brittle, reddish substance.
And that leaves us with one last thought to chew on. Just take a second and look around you right now. Look at the objects on your desk, your phone, a pen, your coffee mug. Using this toolkit we just went through, what hidden physical and chemical properties can you now see in all the everyday objects that surround you?